And what would I call that story? That's true. Okay, here we are. We're 10 seconds in. I haven't even said what set of notes this is. This is 10.3, day number 1. We're going to do some drawing, Roger. Got it. Are you speaking the language now? Oh, okay. What is my name? Love it. My conversation going on here in front of children on the web is very disjoint, so let me get focused here. If you're feeling good about geometry today, or most days, you might like today's lesson. We're going to draw some cubes, prisms, pyramids, and then wedges. What's a wedge? Well, it's one of those things you stick under the door to keep it from closing. All right. We'll get to that in a moment. These are some good review questions. You might want to take a look at these in your free time when you're not on the Netflix or the Instant Book or whatever you guys do. But let's assume for a moment that that's 90. What would this angle measure be? What would that angle be? Nope. 46. We got a problem there. That's not 90. That wouldn't be a 90. Well, this would have to be 46, right? No, you're right. That's 82. Good. Okay. So if that's 82, then we could go ahead and we could find that angle by subtracting those two from 180, and we could do some work here. Find L. What would I do here? Oh, why would I do that when I could use law of sines, but you're supposed to pretend like you don't know that yet, because that's coming next chapter. Okay, I would do this, right? And then I could find this length, and then I know that this is 90, and then I could use, let's see, what could I use? Well, yeah, I could use my brain. How would I find this little angle here? Well, this would be 8. This would be what? This would be 46. So if we call this little angle here y, I know that 8 plus y plus 46 would have to equal 90. And so then I could find y, and I could use trig to find that hypotenuse L. Okay, so there's some right triangle tricks going on there, some of which you may feel comfortable with, some of which you may not, but we need to get there. Second problem, finding distance and bearing. Those we're pretty fresh off of last lesson from yesterday, so we should be pretty good there. But today we're going to do some drawing. Okay. This page really has no purpose other than to give you a palette to draw on. Okay, if you want to practice. But here's what a wedge looks like. This is going to be our primary objective for today. Here's a wedge. Right? I'm going to make a line perpendicular here and here, and then I'm going to connect and connect. And doesn't that look like a little wedge? Yeah, sure it does. Okay, now an attribute about the wedge is that each of these angles there are right angles. And it might be kind of hard to visualize that, but that means that the back and the bottom are both rectangles. Okay, rectangles. So I'm going to sketch and try to sketch this accurately. It might not go that well, but you can see that there's right angles everywhere. Right, except on these triangles. In the back here, there's a right angle. In the back there's a right angle. This is three-dimensional, correct? We're going to be finding some lengths, maybe some surface areas, maybe some angles, etc. You could spend your free time when you're not on, watching Stranger Things or Thomas the Train or whatever, doing some more drawings. I want to jump right into a homework problem. How about that? Okay, this is going to require some colors. So you got colors available to you. For the diagram shown, determine the angle of inclination between the plane ABCD and the base EABH. So I'm looking for this angle measure right here. And that's the angle I'm looking for. Okay. I'm going to give you a couple minutes to do some brainstorming, to work with a neighbor to potentially come up with some kind of trig method to solve. Okay. And I'll give you a head start, and then I'll maybe start with a method that I use. And Roger, go. I'm gonna label some things, but keep working. That's 10. That's 10. That's 12. That's 12. Oh, I should make that solid. This length is 10. Hey, this problem isn't actually as difficult as it looks, right? You don't need that green length of 10, do you? No, you don't need it at all. There's probably a different portion of the problem where it asked for something else, like to find the area of the blue space, right, where you take base times height. But in this case, all that I need to find theta is I just need my friend tangent, because I have a few friends. I'm related to most of them. But I would say that tangent of theta equals 10 over 12, which means theta, I heard someone hollering that out. Is 38 what? 39.8? Okay, so 39.8 degrees. Are we solid there? Okay, now that would be a, if I were to give that a level of difficulty, I'd say that's like B squad gets some time, right, on the varsity court. Right, B squad kid. No, like R2, basic R2, right? Find that angle. Okay, let's up the ante a little bit. Okay, now things are going to get a little bit more interesting here. Let's talk. Thank you for the intro. Okay, let's assume. I think we can safely assume that the base is a square. Okay, we on that. So what kind of triangle would be formed here? Yeah, it doesn't look like it, but that's a isosceles right triangle. So what's that green length? 4 root 2. 4 root 2, right? So if I were to sketch a miniature version of that, that's cute. Right? That right there, children, that would be 4 root 2, if that's an isosceles right triangle. Okay, so what are we looking for? ABC and the base of EBFA. I think we're trying to find the inclination. So we're trying to find this angle? Yeah. Which means both of those measurements that I just found are irrelevant. I think we're going to find the angle of inclination. No, we're gonna find the angle formed between triangle ABC and yeah, the base. It's the base. So this blue angle, right? Now it's not technically that blue angle. It's not. Now I want you to look at this from a profile, okay? Profile meaning side. If I were to sketch a profile view of this, it looks kind of like that, right? Okay, I have to find a special length. This blue length is actually this length, right down the middle. I need that length. I'm not looking for the length of the edge. I'm looking for that length as I look at it from a profile view. You with me? So this angle, theta, should actually look like this. Are you with me? Those two angles are not the same. The angle formed with the edge of the triangle, which is this one, that angle and that blue angle are not the same. Okay, because they don't have the same base length, and they don't have the same slanted side length. Okay, so those two angles are different. So I got to calculate that blue one. How would I do that? Let's talk. This black length right here. How would I find that? Math. Yeah, that's halfway from corner to corner, right? It's halfway from corner to corner. So let's look corner to corner for a moment. I have a square. That's 4, and that's 4. What would that length be? 4 square root 2. What would half of 4 square root 2 be? Okay, so that length is 2 root 2. Okay, now what? Well, I need this length. I need this length right here. Because I want to find the angle between those two segments. Oh yeah, you could do that. That would work. Yeah. Shorten it up. So here, this is 2 root 2. This is 6. So now I could do the inverse tangent of 6 over 2 root 2. What do we get? Somebody give me something here. Okay. Okay, now I want to confirm that this is not the same as this one over here. Right? If we were to look at this angle here that we were looking at originally, we would have had the inverse tangent of 6 over 4. Yeah, so it wouldn't be the same measure. Right? So don't be fooled by this over here. That's not the angle we're looking for. We want to go down the center of that triangle and directly to the center of the base of that corner.